Welcome to the deep dive. We grab complex topics, a pile of sources, and really try to figure out what you need to know.
And today we're tackling a huge one, AI. Is it about to change everything, like tomorrow, utopia, doom, or maybe something else?
Yeah, that narrative is everywhere, isn't it? AI is this almost separate superintelligence.
hmm
But the sources we're looking at today offer a really different take.
Exactly. We're diving into a paper by Arvind Narayanan and Sayash Kapoor from Columbia's Knight First Amendment Institute.
And their big idea, it sounds simple, but it's kind of radical. Yeah. Think of AI as normal technology.
Right. It pushes back hard against all the hype, both the scary stuff and the overly optimistic stuff. They argue that even revolutionary tech, like, say, electricity or the internet, was normal.
Normal how?
Normal in the sense that it was a tool, something we built, something we ultimately figure out how to control and integrate. Normal doesn't mean unimportant, not at all. It just means its path is shaped by us, by human choices, not by the tech itself suddenly waking up.
Okay, I see. So our mission today is to really get inside this normal technology framework. We'll look at why they think the impact might be slower than predicted. What an AI-filled world actually looks like from this view, the real risks versus the maybe overblown ones, and what it all means for policy.
Yeah, it's about grounding the whole AI discussion back in, well, reality, in history, challenging those almost sci-fi assumptions we hear all the time.
Okay, let's do it. First big question. Is AI progress really moving at lightning speed in terms of real-world impact? Is it changing everything overnight?
This is key to their argument. They break down how tech actually changes things into 3 stages. There's invention, the breakthrough, like the basic idea behind a large language model.
Right, the core science.
Then innovation, turning that invention into a product, like an AI coding assistant.
And the third one?
Diffusion, that's the big one. It's the slow, messy process of that product actually spreading through society, getting adopted, and forcing changes in how we work, how businesses run. Everything.
Like retraining engineers to use that coding tool, or companies changing their whole software development process.
Exactly. And their point is diffusion. That's nearly always the slowest part. It has built-in speed limits.
Speed limits on tech adoption. Okay, tell me more. What kind of limits are we talking about?
Well, a huge one is safety-critical stuff. Think about using AI where mistakes are catastrophic. Criminal justice predictions, healthcare.
Right.
The paper gives this example of a sepsis prediction tool from Epic, the big health software company.
Oh, yeah, I think I heard about this. Looked great in the lab, but not so much in actual hospital.
Total failure, pretty much. Missed loads of cases, tons of false alarms. And a key reason the paper points out was that it was trained using information like whether a patient already had antibiotics.
That you wouldn't know before diagnosing sepsis in the real world.
Precisely. Finding those kinds of subtle, real-world flaws in complex AI, it's incredibly hard, takes ages.
And we see this even now, right? Like Bing's chatbot going weird early on, or Gemini making those historically off images, stuff that testing just didn't catch.
Absolutely. It shows getting AI right in the messy, unpredictable real world is just really hard. So in areas with high stakes, regulation FDA rules, the EU AI Act acts as a necessary brake. And honestly, it should. Safety's got to come first.
Okay, so safety and just the sheer difficulty of making AI reliable in the wild, those slow things down. What else? Even when it's not life or death.
Even then, people, organizations, institutions, they just change slowly. It's inertia. The paper notes, like, okay, lots of people say they use generative AI now, maybe 40% of U.S. adults.
Yeah, seems high.
But studies looking at actual work find the impact is still tiny, maybe 0.5% to 3.5% of work time. Just because it's available doesn't mean it's deeply integrated yet.
It's like getting new software at the office.
Yeah.
Install it, maybe play with it.
Yeah.
But actually changing your whole workflow, that takes ages, if ever.
That's a perfect analogy. And they use the classic Paul David electrification example, too. Electric motors existed for decades before factories saw big productivity gains.
Why so long?
Because it wasn't just about swapping steam for electricity. You had to totally redesign the factory floor, change how work flowed, update management, retrain everyone. That kind of deep change takes decades.
Okay, so diffusion is slow, safety concerns, human inertia. What about the step before that innovation? Turning the AI methods into useful applications. Are there speed limits there too?
Definitely. They talk about the capability-reliability gap. AI models get better on tests, sure, but making them robust and reliable in the real world, much harder. Self-driving cars are the poster child for this, right?
Yeah, billions spent, decades of work, still not really here for most people. Because safety demands near perfection.
Exactly. And for other complex stuff, like an AI travel agent booking a complicated trip, a small error in the real world can be way more costly than just getting a question wrong on a test.
Makes sense.
Plus, you've got barriers like tacit knowledge that stuff workers just know how to do that's hard to write down or teach an AI. And privacy concerns limit data for training, especially in sensitive areas.
They also mentioned something called the bitter lesson. Gets talked about a lot.
Yeah, and they say it's often misunderstood. The original idea was that general methods plus lots of computing power tend to beat human-designed rules when developing the AI methods themselves. But that doesn't magically make building real-world applications easy.
So even if the core AI is smart, building a useful product around it is still hard work.
Tons of work. Think about recommendation engines. They use fancy AI, but still need huge amounts of regular coding for the user interface, business rules connecting to other systems.
And what about learning new things, like
Yeah.
in science or economics?
Right. Pushing those frontiers often needs real-world experiments, clinical trials, testing economic policies. You can't just unleash untested ideas on millions just to feed data to an AI. Society puts, and should put, limits on how fast we experiment in those domains.
This makes me think about those headlines, GPT-4 passing the bar exam, stuff like that. The paper isn't impressed.
Not really, no. They argue those benchmarks measure a very narrow slice of capability, like memorization and recall, which AI is great at. But they miss the stuff that actually makes a good lawyer.
Like judgment, creativity,
Yeah.
persuading a jury.
Exactly. Stuff that's way harder to measure with a standardized test. It's what academics call a construct validity problem. The test isn't really measuring the thing you care about, like being a good lawyer or being a skilled engineer.
So the high scores don't automatically mean AI can do the whole job.
Right. And studies looking at how AI actually helps people on real tasks. Uplift studies, they generally show modest gains, augmentation, not wholesale replacement.
So using these narrow tests to predict when AI will reach human-level intelligence is kind of defining intelligence down to whatever the test measures, moving the goalposts.
That's exactly their critique. So you add up all these speed limits on diffusion, on innovation, even on how fast we can learn new things safely, and it suggests sudden, massive economic disruption is unlikely.
It's more gradual, sector by sector.
Yeah, the real impact comes from those slow feedback loops between making new tools and society actually adopting them. And as some tasks get automated, people shift to new tasks, maybe tasks AI creates. The goalpost for AGI taking all jobs keeps moving.
Okay, that's a really clear picture of the speed argument. So let's shift then. If we buy this normal technology idea, if AI isn't this runaway superintelligence, what does a world with really advanced AI look like, according to this paper?
Well, they suggest we stop obsessing over intelligence, which is slippery anyway, and focus instead on power.
Power, as in the ability to actually change the world around us.
Exactly. And humans get power mainly through technology, right?
Yeah.
Modern humans aren't necessarily biologically smarter than our ancestors, but we have vastly more power because of tools, knowledge, technology, including AI.
So the superintelligence idea confuses like raw processing ability with actual real-world influence.
That's the argument.
Okay.
And our intuitions from games like chess or Go, where AI dominates, they can be misleading.
How so?
Because in games, speed and calculation within fixed rules are key. AI crushes that. But most real-world situations aren't like that. Speed isn't the bottleneck. And for the rare cases where it is, like, say, controlling a nuclear reactor second by second.
We build specific automated tools, but a human is still in charge overall.
Precisely. The AI doesn't decide to melt down the core because it feels like it. It's a tool under human supervision.
Okay. And they make a strong claim about irreducible error.
Yeah, this is a big prediction. They argue that for many complex, real-world cognitive tasks, forecasting geopolitical events, doing cutting-edge science, genuinely persuading someone against their core interests, AI won't significantly outperform trained humans or maybe human AI teams. There's a baseline level of error or uncertainty that computation alone can't beat.
What about those studies showing AI can persuade people?
They critique those for lacking ecological validity. Getting someone to click a button in a lab isn't the same as convincing them to do something difficult or costly in the real world. The stakes and context are totally different.
Okay, so if AI isn't this godlike intelligence and it hits limits in complex tasks, then controlling it, that becomes a much more manageable problem.
Absolutely. It shifts the focus away from trying to solve the near-impossible alignment problem, making AI perfectly good, or the impractical idea of humans approving every single tiny AI action.
There are other ways to control tech. more normal ways?
Loads of them. Stuff we already do. Auditing systems, monitoring performance, building in fail-safes and circuit breakers like in engineering, basic cybersecurity hygiene, least privilege, access controls, even simple things from interface design like making AI actions easily undoable.
And even the technical AI safety research. Maybe it hasn't solved the superintelligence problem, but it's given us useful tools for controlling normal AI.
Definitely. Things like using AI judges to check other AIs, systems that escalate tricky decisions to humans, making AI reasoning more transparent, hierarchical control. These are practical engineering solutions for managing powerful tools, not trying to bottle up a genie.
This view also changes how we think about jobs, right? Not just replacement, but change.
A big shift in what human jobs are. They predict more and more human work will involve controlling AI systems and telling them what to do. They use Karen Levy's research on truck drivers as a great example.
Oh, right. Self-driving trucks seem like total automation, but drivers do way more than just drive.
So much more. Checking the cargo, inspections, security, maintenance, customer interaction, paperwork. A lot of that is fundamentally about control, oversight, and managing exceptions. The future of many jobs might be less about doing the core task and more about managing the AI that does it.
And this shift, they think, will be driven by the market because unreliable AI is bad for business, but also shaped by regulation.
Yeah, regulation can nudge things in the right direction, ensuring safety and proper oversight becomes standard practice. It paints a picture of AI as powerful tools, firmly under human control, with jobs evolving alongside them.
Okay, that perspective really changes how you'd approach AI risks. So, Part 3. What are the real risks if AI is just normal technology?
The focus shifts away from, existential doom from rogue AI. Instead, the main risks come from people and organizations using AI, often in ways that make existing problems worse.
So, accidents can happen, but it's more like an industrial accident. The deployer is responsible.
Pretty much. And the solutions are familiar. Market pressure, bad AI fails, and regulation, setting safety standards. Though they do note that having just a few huge companies controlling the core AI is maybe a bigger systemic risk than isolated accidents.
What about AI arms races? That sounds pretty bad.
They frame this as an old problem, actually. A feature of capitalism, sometimes the race to the bottom on safety. Companies cut corners to get ahead, pushing the costs onto society or workers. Think about the Industrial Revolution. Unsafe factories, dangerous mines.
Until regulation stepped in and forced companies to, install safety guards or pay for inspections, internalize the costs.
Exactly. Regulation forces accountability. They use self-driving cars again here.
Comparing Waymo's cautious approach to others who are maybe more aggressive.
Yeah, suggesting that so far safety seems to correlate with market success, and regulation, like pulling licenses after crashes, plays a crucial role.
But isn't social media an example where that didn't happen so well? Harm was externalized, regulation was slow.
It's definitely a harder case. Pinpointing harm from algorithms is tougher, which just highlights why we need to be proactive with AI, gather evidence, and try to anticipate these issues.
What about country versus country, the US-China AI race? Is that an arms race?
They distinguish between an innovation race, who builds the best tech, and a reckless adoption race, who deploys potentially unsafe stuff fastest. They argue a safety arms race between countries is unlikely for most AI.
Why not?
Because the fallout from most AI failures is local. A biased hiring algorithm hurts people in that country. An unsafe autonomous system causes problems there. There isn't the same global strategic pressure as with, say, nuclear weapons.
Ah, the nuclear power versus nuclear weapons analogy.
Right. There wasn't a global race to build potentially unsafe nuclear power plants everywhere because the risks, like Chernobyl, were local, leading to strong domestic pressure for safety. They argue countries shouldn't sacrifice local safety for some hypothetical global AI win.
Okay, so arms races are more of a familiar regulatory challenge. What about misuse?
Yeah.
People using AI for bad things.
This is a big one. Their key argument here is that the main defense is not trying to make the AI models themselves perfectly aligned or incapable of doing harm.
But isn't that what alignment research aims for?
It tries, but they argue it's fragile and models lack context. Think about writing a phishing email. The AI writing the text isn't the core problem. The harm is the human attacker using that text in a larger scam, setting up fake websites, targeting victims. The AI doesn't understand that whole malicious plan.
So trying to block harmful requests at the model level is either too blunt, blocking legit uses, or too easy for bad actors to work around.
Exactly. A motivated attacker will just rephrase or use a less restricted model, so defenses need to be downstream.
Closer to the actual harm, like spam filters, security software, training people.
Precisely. Existing defenses we already use may be boosted by AI itself, and that's critical. AI is also a tool for defense.
Right, for finding security holes, detecting biothreats, fighting fraud.
Yes. And they worry that overly restricting AI development out of fear of misuse could actually disarm the defenders, while the attackers, who ignore rules anyway, still get the tools. The focus should be improving that offense-defense balance, maybe by getting AI to the defenders.
Makes sense. Okay, next up. Catastrophic misalignment, the big existential worry. How does the normal tech view see this?
They frame it as a speculative risk, meaning we have genuine epistemic uncertainty about whether the risk is even real, let alone how likely it is. It's not like climate change where the basic science is solid.
So the paperclip maximizer thought experiment.
They critique it. They argue it makes unrealistic assumptions about deployment. Would we really give a system that literal-minded and lacking common sense that much power without noticing major problems much earlier in less critical tests? Real-world deployment involves checks and balances.
What about an AI pretending to be aligned but secretly plotting? Deceptive alignment.
They see it as a very hard engineering challenge, but likely detectable. As AI interpretability improves, we should get better at spotting it. Defenders have advantages. They can stop the system, look inside, run tests, and all those downstream controls still apply.
Plus, real-world decisions aren't made by one AI in a vacuum. There are institutions, human oversight.
Exactly. They acknowledge AI optimization can go wrong. We see it in game AIs finding weird loopholes. But in the real world, that's far more likely to just make the AI ineffective or cause localized problems, not global catastrophe. So it's a risk worth researching, but not necessarily the most pressing one.
Which brings us to what they do see as the most pressing risks, systemic risks.
Yes. Not maybe extinction level, but potentially devastating on a societal scale. Things we're already grappling with, but supercharged by AI.
Like what specifically?
Systemic bias and algorithms causing unfairness. Major job losses without good transitions. Worse working conditions due to AI surveillance. More economic inequality. Power concentrating in a few tech giants. Erosion of trust because of deepfakes and misinformation. Damage to journalism. Democratic backsliding fueled by targeted propaganda. Mass surveillance. Helping authoritarian regimes.
Wow, that's a long list.
It is, and the crucial point is, these arise not from AI acting alone, but from people and organizations using AI in ways that exploit existing societal weaknesses.
Like the Industrial Revolution again. Not the steam engine's fault, but how it was used within the existing society.
Exactly. Massive disruption, inequality, exploitation caused by humans wielding new tech in flawed systems. That's the kind of risk they see as most likely and needing the most attention with AI.
Okay, this totally reframes the safety debate. So if that's the risk landscape, what does it mean for policy? Part 4.
This is tricky because we have these two competing views, normal tech versus superintelligence, and the policies for one might be bad for the other. That uncertainty creates a real dilemma.
Like centralizing AI control might seem good against superintelligence, but bad if it's normal tech because it concentrates power.
Precisely. And they argue trying to compromise or calculate expected utility, like what's the probability of each future, just doesn't work.
Why not?
We have no reliable basis for those probabilities. The consequences are unknown. And people fundamentally disagree on what values matter most. Is avoiding extinction the only goal? Or do fairness, freedom, and well-being count too? Value pluralism makes simple calculation impossible.
So what do we do? Policy needs justification.
Right.
Especially if it limits things.
Given the uncertainty, they push for policies based on value pluralism acceptable across different value systems and robustness.
Robustness meaning?
Policies that are helpful, or at least not harmful, regardless of which future unfolds. Or policies where we understand the risks if we're wrong.
So a key policy goal should be just reducing the uncertainty, finding out what's actually going on.
Yes. Since we don't know the future, let's get a much better grip on the present. Fund research on current downstream risks. How are bad actors using AI now? How does bias actually play out?
And put in place evidence-seeking policies, things designed to gather information.
Exactly. The paper lists things like protecting AI whistleblowers, mandatory transparency reports, public lists of government AI use, product registration for risky AI, incident reporting systems, safe harbor for researchers who test systems, red teaming, generate data.
And guide policymakers on what evidence is actually useful, make evidence gathering part of evaluating policies themselves.
Right. Are we actually learning what we need to know?
Beyond reducing uncertainty, the big policy theme they advocate is resilience.
Yeah, drawing on work by folks like Marchant and Stevens. Resilience isn't about perfectly preventing all harm that's impossible with new tech. It's about building systems, social, economic, technical, that can absorb shocks, manage change, and bounce back, aiming for a soft landing.
Better than traditional risk assessment or liability, which struggle with AI's novelty.
They argue it is. Resilience strategies include no-regret policies, stuff that's good anyway.
Like what?
Strengthening democracy, supporting free press, protecting labor rights, basic societal health. Also funding research, transparency, building expertise, and universal interventions like early warning systems, digital defenses, incentivizing defenders, reporting channels.
Seems sensible. Things we should probably do regardless of AI.
Pretty much. Then there's a trickier category. Policies that boost resilience if AI is normal tech, but might clash with controlling superintelligence.
That's where things like promoting competition, open source AI, and decentralized control come in.
Exactly. If AI is normal tech, diversity and decentralization make the system more robust. One failure doesn't crash everything. But if you fear one rogue AI, you might want centralization. The paper suggests cautiously pursuing these resilience policies, but being ready to adapt.
Okay, so they champion resilience. What do they argue against?
They strongly argue against non-proliferation policies.
Trying to limit who gets access to powerful AI models, like export controls or banning open source releases.
Yes. It sounds intuitive if you fear a superintelligence escaping, right? Keep it contained.
But they say it won't work.
Fundamentally infeasible, they argue. The knowledge is spreading, costs are dropping, bad actors won't follow rules anyway, and enforcement would require insane levels of surveillance.
And it creates new risks.
Big ones. Less competition means more market concentration, maybe single points of failure like a software monoculture. It limits the number of experts who can actually study safety, restricting it to a few big labs.
What about using it to stop misuse, like AI for bioweapons or cyber attacks?
They circle back. Defenses are downstream. AI helps defenders too. Limiting AI broadly hurts the good guys more. Trying to solve biosecurity just by restricting AI misses the point and disarms us.
So non-proliferation reflects a mindset of top-down centralized control.
Whereas resilience favors decentralized control, empowering users and deployers with multiple layers of defense. They list examples of non-proliferation ideas and argue they mostly reduce resilience and could ironically make a centralized superintelligence more powerful by removing checks and balances.
Okay, one last area, realizing the benefits. If AI is normal tech, the good stuff doesn't just happen automatically.
Not at all. Diffusion needs help. Roadblocks exist. Maybe companies lack the skills to adopt AI effectively. Bad policy can also hinder things, clumsy regulation that doesn't understand the tech, or binary views of automation that stifle human-AI collaboration.
But good regulation can enable diffusion.
Definitely. Like laws clarifying electronic signatures helped e-commerce. Clear rules for drones helped that industry grow. Good regulation creates trust and predictability. It can also protect those potentially harmed, like journalists.
And governments need to invest in the complements to AI.
Hugely important. Things the market won't provide enough of. Widespread AI literacy, workforce retraining, better digital infrastructure, open data initiatives, upgrading the power grid for more compute. These are public goods that unlock AI's value.
And thinking about sharing the benefits.
Yeah, stronger social safety nets for those disrupted. Maybe finding ways to fund things AI might displace, like arts or journalism, perhaps through specific AI taxes.
What about government using AI itself?
A balancing act. Don't rush in and deploy bad systems that erode trust like that NYC chatbot mess. But don't be so slow and bureaucratic that government falls behind, outsources key functions, and loses legitimacy. Find the right pace, guided by public value.
Wow. Okay. This has been incredibly illuminating. It really shifts the focus from science fiction scenarios to historical patterns and practical challenges.
It forces you to consider how major technologies actually integrated into society, how we adapted, how we regulated, how we shaped them over time. It wasn't usually instant revolution.
So for everyone listening, we've really unpacked this core tension. AI as this imminent, maybe uncontrollable superintelligence versus AI as powerful but ultimately normal technology.
And we've seen how these fundamentally different starting points lead to different interpretations of the evidence, like benchmarks versus real-world diffusion and totally different policy prescriptions, non-proliferation versus resilience.
Understanding this clash of worldviews is just crucial if you want to make sense of the AI conversation right now.
Right.
It explains why smart people can look at the same thing and see completely different futures. So here's a final thought for you to take away from this deep dive. The next time you see a headline about AI, maybe it's amazing, maybe it's terrifying, how might you evaluate it now? Can you start to separate the reporting on cool new capabilities from the much slower, messier reality of how technology actually spreads, changes industries, changes society, and ultimately impacts your life, especially if you consider it through this lens of AI as normal, controllable technology?